In this video, we're going to learn how to make a horse racing game using C, and the final game is going to look like this. The horses will race from the right-hand side to the left-hand side of the terminal until we have a winner. So let's build the application now. First off, these horse and trophy characters here are pretty unusual UTF-8 characters, so what I've done is just found them using online websites like this, and then I've taken them and copied them into the text editor here. So that way we already have them. Now the first thing we'll do is use preprocessor macros, what are also called preprocessor constants, to define the number of horses and the length of the track. So we'll have num horses, and we'll have 4 horses initially. We'll also define the track length, and we'll have a track length of 30 initially. Then we'll declare an int type array called positions of the length num horses to store the horizontal position of each horse on the terminal. Now we're going to begin each horse at the position track length -1 on the right hand side of the terminal. So we'll have here a for loop to do that. We'll have for int I is equal to 0, I is less than num horses, and I++. So the loop counter variable I is going to go from 0 by 1 with each loop iteration to the index num horses -1. That means this loop is going to run for each index in that array. And we'll set each index in the array equal to track length -1. So that way each horse begins towards the right-hand side of the terminal at the beginning of the track. Next, let's create a function to output the status of the race based on the positions of the horses. And we'll end up calling this function repeatedly to animate the game. But first, let's just define the function. So the function is going to have a void return type. It's not going to return any values. It's just going to output the status of the race. We'll call the function itself print race. The function is going to be passed the positions array as an argument, so we'll have the parameter int positions for that array. Then we'll use a for loop to go through each horse in the race. So we'll have the counter variable I go from 0 all the way up to, but not including, num horses by 1 with each loop iteration. Then we'll have this inner loop that's going to output the status of the horse on the track. We'll first output here this vertical bar character here to represent the end of the track. Then we'll have the inner for loop where we're going to have a counter variable j go from 0 by 1 up to, but not including, track length. So this loop is going to run track length number of times. And most of the time, what this loop will do is output a dash to represent a portion of the track. But if j is equal to the position of the horse in the positions array at the index I, then we're going to output the horse. So here we'll output here, using printf, the actual horse. So we'll have here this horse. Otherwise, we're going to output this dash to represent a portion of the track. Now, once this is done, we'll output a vertical bar to represent the beginning of the track. Then we'll output the horse number. So we'll have horse and %d to output an integer, followed by \n for new line. And we'll output here I+1 to output the horse number, horse 1, horse 2, horse 3, and so on. Then down here, we'll call the print race function. So we'll call print race like this, and we'll pass in the positions array. We'll save this and compile the program and run it. And we get here the correct initial status of the game with each horse on the right-hand side of the terminal at the beginning of the track. We have each horse number, horse 1, horse 2, horse 3, and so on. The horses will have to be animated such that they move towards the left-hand side of the terminal, towards the end of the track here. Now the outer loop is outputting these rows here, these lines here, and the inner loop is responsible for outputting each track and the position of the horse on that track. So next, let's finish this game by animating the horses. So one more thing I'm going to do in this function here is add a call to the flush function. And what I'll pass it here is std out, like this. And this function call here is just to make extra sure that all the characters we've just output are going to be on the terminal. And that's because when we call printf, the characters are going to be output to standard out, which by default is going to be connected to the terminal. But standard out can be buffered, which means the characters can be placed into a temporary place in memory before actually being placed onto the terminal. By calling flush std out, what we're doing is making absolutely sure that all these characters have been output to the terminal. Next, let's actually animate the game. So we're going to move the horses by some random number of positions. What we'll have to do is generate random numbers. To do this, we'll include the stdlib.h library, which includes the function rand to generate random numbers. We'll also include the time.h library so that we can seed the random number generator. So down in the main function, we can call the rand function and have it return a random integer. What we want to do though is ensure we get a potentially different sequence of random numbers each time our program runs. C uses what's called pseudo random number generation, where what we have to do is provide a seed value that's going to be different each time the program runs in order to ensure the sequence of random numbers returned by rand can be different each time the program runs. We'll call the srand function to provide that seed value, and we'll use the current time as the seed value because the current time is going to be different each time the program runs. If we call the time function and pass it null, we're going to get back as a return value the current time, which will cast to unsigned int, which is what the srand function expects. So now down here, when we call rand, we're going to get a random integer in the range of 0 to a very large positive integer. What we want to do though is have a random integer in the range of 0 to 2, because we're going to move our horses by 0 to 2 positions each time this loop runs, which animates our game. So what we'll do is take this value and divide it by 3 using modulus. So this percent here is the modulus operator. What it does is a division, but it returns the remainder of that division. So if we take a number in this range of 0 to some very large positive integer, and we divide it by 3, the only possible remainders are 0, 1, and 2. So we'll use this to generate at random the amount of positions for each horse to move. Now let's use a loop to animate each horse. What we'll have is a while loop, and initially let's have this loop run forever. We'll have while 1, where 1 evaluates to true, so that way this loop runs forever initially. Then in here we'll have a for loop to determine the new position of each horse. We'll have here for int I is equal to 0, I is less than num horses, and I++ to again go through each horse. Then what we'll do is have positions at the index I minus equals a random number, either 0, 1, or 2, as determined by this expression. And what minus equals is going to do is take positions at the index I, subtract the random number, either 0, 1, or 2, and store the result back into positions at the index I. So for each horse, what we're doing is subtracting at random either 0, 1, or 2 from their position to move them towards the end of the track. Now, if a horse has a position that is less than or equal to 0, then this means the horse has reached the end of the track. And what we'll do is set positions at the index I equal to 0. It's possible that by subtracting more than 1, the position of the horse is actually negative at this point here. But what we'll do is set it equal to 0 to have the horse placed at the last point in the track. Now, what we'll have to do is, after updating each horse's position, we'll have to print the state of the game again using the print race function. So down here, we'll call print race, and we'll pass it the updated horse positions like this. And so what we're going to do is continuously update the positions of the horses and then redraw the state of the game to the terminal. This is what we could call a crude game loop. Most games work with what's called a game loop to produce the effect of animation. So what will happen is the positions of characters and enemies and whatnot will be updated according to the logic of the game. Then the state of the game will be redrawn to the screen. And if that happens many times a second, that will give the effect of animation, where we have a certain number of frames per second when playing a game. So with this here, we're missing a few things. One is we need to redraw the game over top of the existing output of the game. So right now, we have this view of the game with the horses at the beginning. In order to have an animation effect, what we need to do is start drawing the game again right here, right where we drew it last time. So that way we overwrite this current output of the game. To do this, we're going to use what's called an ANSI escape sequence to tell the terminal to move the cursor. So an ANSI escape sequence will allow us to tell the terminal that we want to move the cursor back somewhere else. So down here, we'll call printf and we'll pass it the string \033 and then open square bracket and then %d a like this. And then we'll have here num horses. So this here is what's called an escape character. What it's doing is telling the terminal to expect an instruction next. So this is not going to be output. This is actually communicating with the terminal and telling it to expect an instruction next. Then this open square bracket here is the control sequence introducer. Then we have the actual instruction here, where we're going to output here the number of horses and then uppercase A. And what that means is move the cursor up this many lines. So the cursor is going to move from here up this many lines to here. And then we'll begin outputting the new status of the game where we began before, and we'll overwrite the old status of the game. Now we need one more thing to have the effect of animation, and that is a slight delay in between every time we draw the state of the game. Otherwise, what's going to happen is this loop is going to run so fast that we never actually see the horses move because it all happens so quickly. So we need to pause the program for some short amount of time, maybe something as small as 200 milliseconds. A sleep function can be used to pause a program for a short amount of time like this, but different systems have different sleep functions. So on Windows, there is one sleep function, whereas on POSIX systems, which are basically Unix-like systems like Mac OS and Linux and so on, there is a different sleep function. So we're going to build our own special sleep function to handle the situation. Up here, what we'll do is include either the right library for Windows or the right library for POSIX systems. And we'll use a preprocessor directive to do this. So if we're on a Windows system when compiling the C program, a preprocessor macro _win32 is going to be defined. And we'll check for this using a preprocessor directive. We'll have here $, if defined. So basically here we're saying if we're on a Windows system, then we're going to include the windows.h library where the Windows sleep function is defined. Otherwise, if we're not on a Windows system, then we're on a POSIX system, and we're going to include here uni_std.h, where the POSIX sleep function is defined. And then we'll have end if. So this here is a preprocessor directive. It's going to run as the first stage of compilation. And we're going to include either windows.h or uni.std.h, depending on what kind of system we're on when compiling this program. This will allow us to include the right library for that system. And like I said, this happens at the preprocessor compilation phase. So it's as if something passes over our source code first and determines which of these libraries to include. Then the source code file will be compiled further from there. Now we can also define our own sleep function that's going to call the correct sleep function depending on the system that we're on. So here we'll have a function called sleep underscore milliseconds to sleep a certain number of milliseconds. We'll have the parameter int milliseconds for that number of milliseconds to sleep. The function can have a void return type because the function is not going to return anything. It's just going to sleep the program for a certain number of milliseconds. Then inside the function body, we'll call the correct sleep function for the platform that we're compiling the program on to sleep the program for this number of milliseconds. So again, we'll use the preprocessor directive here. We'll have number sign if defined win32. And if we're on Windows, we're going to call the Windows sleep function, which is called sleep, and we'll pass it milliseconds. And this will sleep the program for this number of milliseconds. Otherwise, we'll have else, and then end if. And we'll have here a call to usleep, which is the POSIX sleep function. And this function accepts microseconds. So what we'll do is take milliseconds and multiply it by 1000 in order to sleep the program for this many milliseconds. We're basically doing a conversion of milliseconds to microseconds. Now, again, the same sort of thing is going to happen where the preprocessor is first going to pass through the source code and then insert either this function call or this function call. Then the program is going to be compiled from there. So down here, we can call sleep ms. So we'll call sleep ms. We'll do this right before redrawing the state of the game, and we'll pass it 200 to sleep for 200 milliseconds. So let's save this and try it out so far. So we'll save it. We'll recompile the program, and let's try it. And we can see here the horses are animating their way across the terminal, and once they reach the end, they're going to stop. So the next step is to determine which horse won. We could have a situation where multiple horses reach the end at the same frame of animation. If that's the case, what we're going to do is just randomly determine which horse wins. So the next thing we'll do is make an int type variable called winner to store the ultimate winner of the race. Then we'll have an int type array called winners of the length num horses. And what this array is going to store is the horse numbers of all the horses which cross the finish line during the last frame of animation. In other words, all the potential winning horses. And we'll select from this array at random the ultimate winner horse. And we'll keep track of the number of horse numbers that are stored in the winners array with the total winners variable of the type int, which we're going to initialize to 0. And we'll keep this loop going so long as total winners is equal to 0. So we'll have here while total winners is equal to 0. So long as we have no winning horses yet, this loop is going to continue. But once we have at least one winning horse, the game is going to stop. Now down here, once a horse does cross the finish line, we'll add them to the total winners array. So we'll have winners at the index total winners is equal to I, which is effectively the horse number. Then we'll increment total winners by 1. So that way, if we have another winning horse, they'll be stored into the next index of this array here. Then once this is done, all we have to do is randomly select from the winners array the winning horse. So the winners array is going to store at the indexes from 0 to total winners minus 1 the numbers of the winning horses, what we'll do is just randomly select one of these horses. If we call rand, which gives us a random integer in the range of 0 to a very high positive integer, and we do modulus total winners, what this will give us is exactly this, an integer in the range of 0 to total winners minus 1. So we're going to randomly select one of these horses, and we'll assign this number to winner, which keeps track of the ultimate winner of the race. Then we can just output which horse won. So let's grab the trophy up here. We'll get this trophy, and we'll cut this. And then down here, we'll call printf, and we'll put new line, horse with this number wins the race, followed by a new line, and we'll put the horse number of the winner. So winner plus 1. Then if we save this and compile the program and run it here, we should have a winner now. It's a close race, but horse 1 wins. Let's try it again. Again, we got horse 1. We'll try it one more time. Oh, come on, 4. Horse 4 wins. Okay. Now we could change the number of horses and the length of the track. Let's try that. So let's change it so we have 8 horses instead. So here we'll have num horses 8. And we'll try a track length of, let's say, 40. So we'll save this and compile the program and run it. And now we have 8 horses and a longer track. And horse 8 wins. So this is how we can make a horse racing game using C.
Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.